Hey, Mr. Simon here. We're going to do 5 method and control structure FRQs. We know that one of the 2 FRQs on this year's exam is going to be what they call a method and control structure FRQ. Well, that to me it seems pretty vague. Method's just another name for function, so we know we're going to be writing at least one function, and it's going to have at least one control structure, which could be an if statement or a loop. This category of FRQ seems like it could really be anything to me, but I've noticed a pattern. Often this type of FRQ is kind of mathy, and we're going to see some of that in the 5 that we're working through. We're going to have 3 that are due this week. The check digit, delimiters, and HOPO FRQ. Check digit, as you might guess, is kind of mathy, and HOPO is kind of mathy. It's similar to a famous unsolved math problem called the Collatz conjecture, which is interesting if you like that kind of stuff, but it's not necessary just to do the problem. Then we're going to have 2 more that are due May the 8th, the frog simulation, which uses random numbers, and another kind of mathy one, the AP calendar. That was from 2019. So 2019 actually had a couple of mathy problems on it between check digit and the, well, check digit actually is the course description problem. But yeah, there's some mathy ones here. So we're going to start with check digit, and make sure you read all the instructions. This is the number one mistake that people make. So when you go and you look at the instructions, down at the very bottom, it says you must use these other functions, get number of digits and get digit, in order to get credit for this, right? So get number of digits will take any number, and it'll tell you how many digits it's got. And get digit will take any number, and then you give it a place. And so this is going to give us the digit in the first place, right here where the 2 is, for that number. If we do the same number, but we give it place 5, well, 1, 2, 3, 4, 5, that's going to give us the 1, which is the 5th digit, or in the 5 place, or however you want to say it. So watch out for that. And then in part B, you're going to be using, or it's really helpful to use this technique that they just love on the AP exam. It's how you can split a number into the ones digit and all the rest of the digits using mod 10 and divide by 10. So if we have a number like 1, 2, 3, 4, 5, 6, 7, and we do modulus 10, the remainder, when we divide by 10, is going to be whatever the ones digit is. If we want to get the rest of the digits, we divide by 10, and that'll give us all the digits except the ones digit. And so we can split one number into 2 parts, the ones digit and the other digit. This is a common thing on the AP exam, and this is not the first time we've seen it. There were a number of coding bat problems that used this trick of mod 10 and divide by 10 to split a number into 2 parts. And this would not be a bad time to go back and kind of review them. And then I've added one more mathy kind of problem. This is optional, but in the January issue of Games magazine, they had a neat puzzle problem. It was a contest, actually, to ask, where you had to look for a 7-digit number that had a couple unusual characteristics. And again, this is one where, the mod 10 divide by 10 thing can be helpful. So even though we did these recursively when we did them on Coding Bat, that's not necessary. So you might want to go back and redo these as non-recursive functions. So we've got a couple different variations on this. So in some digits, we want to add up all the digits. So I'm going to get the ones digit with mod 10, add that to a sum, and then I'll eliminate that ones digit by dividing by 10. So n equals n divided by 10 means n is now the rest of the digits other than the ones digit. And I'll keep repeating this process till I get down to 0. And I've done it again here on count 7. Here, I'm just checking to see if that ones digit is a 7. If it is, I increase the number of 7s. But same process, n equals n divided by 10 is how I'm one by one dropping off each of those ones digits until the number is 0. So might be worth taking a look at that and practicing before you do today's or this week's FRQs. You're going to notice that some of them are static. You don't care. When you're coding a static function, you're going to code it the same way as you would otherwise. Static functions don't use private member variables, but the classes that we're working with don't have any private member variables. So you're not going to get confused. You're not going to mess it up. Just, code it the way you would, and just don't worry about the word static. When you're writing a function, it just really doesn't make too much difference. So answers start on the next slide, 110, for the next 5 FRQs. So take a look at it. And as always, don't hesitate to contact me if you've got any questions. Thanks for watching.